Here, in this lesson, I will discuss the answers of the mock test 7. Here, we will discuss the second part of the question paper, that is from question number 25 to question number 45. Let us take the first question, that is the question number 25. Here, a particle is moving on circular path as shown in the figure. A particle is moving in the circular path in the anticlockwise sense. The displacement from P1 to P2 is. So, the displacement from P1 to P2, the particle has gone through the arc from P1 to P2. So, its displacement is this line only. This line only. So, from the property of triangle, we may write down that if the displacement is r, then r square equals to small r square plus small r square minus 2 small r into cos theta. So 2r square into 1 minus cos theta. That is 2r square into 2 sine square theta by 2. So capital R equals to 2r sine theta by 2. So our answer is D. Correct choice to the question number 25 is D. Now see the question number 26. In question number 26, a boatman can row with a speed 10 km per hour in still water. River flows at 6 km per hour. If he crosses the river from one bank to the other bank, along the shortest possible path, time taken to cross the river of width 1 km is. Here, the velocity of the river flow is 6 km per hour. It is given by the vector OA, or it is represented by vector OA. And the speed of the boatman of the boat is 10 km per hour. He crosses the river from one bank to other along the shortest possible path, that is the perpendicular way, perpendicular to the flow of river. So we will get OC as the resultant vector. So the resultant velocity will be given by the vector OC. If OA is 6 km per hour, then BC is also 6 km per hour. So let OC equals to V. Then from the property of right angle triangle, V square plus 6 square equals to 10 square. So V square equals to 10 square minus 6 square. That is your 10 plus 6, 16 into 4. So V equals to root over of 16 into 4, that is your 8. The velocity is 8 km per hour. So it will take to row a distance 1 km is 1 by 8 hour. So our correct answer to the question number 26 is A. So correct answer to the question number 26 is A. Now let us take the question number 27. A particle of mass m is attached to 3 identical springs A, B and C. 3 identical springs A, B and C. A particle m is attached a force constant k, each spring having force constant k. If the particle of mass m is pushed slightly against the spring A, if it is A, this is B, this is C. If it is pushed slightly against A and released, then the time period of oscillation is. Then we have to calculate the time period of oscillation. Let us first of all take the extension of A as x, whereas that of the they are at an angle 45 degree actually here. This should be mentioned in the diagram. So the stretching of the spring B is x by root 2 and that of C is also x by root 2. Let the velocity of the mass be V. So from energy conservation law, we can write down the mass having kinetic energy half mv square. plus the potential energy stored in the first spring is half k into x square, and that in the other two springs half k into x by root 2 whole square. For the two springs B and C, total energy should be half kx by root 2 whole square into 2. This is constant. So half mv square plus half kx square. Here 2 cancel out from numerator and denumerator. This is kx square by 2 and here is kx square by 2. So the total kx square equals to C. Now differentiating equation 1 with respect to x, we get half m into 2v dv dx plus 2kx equals to 0, 2 being cancelled out. mf m into f, that is a, plus 2kx equals to 0. So a equals to minus 2k by m into x. A equals to minus omega square x. From the equation of SHM we get a equals to minus omega square x, and comparing equation 2 and 3 we at once get omega equals to 2k by omega square equals to 2k by m, hence omega equals to root over 2k by m. We have to calculate the time period of oscillation. Time period of oscillation t equals to 2 pi by omega equals to 2 pi root m by 2k. 2 pi root m by 2k. So B is our correct choice. So for the question number 27, it is B is the correct answer. Now let us take the question number 28. In question number 28, when an oscillator completes 100 oscillations, its amplitude reduced to 1/3 of its value. What will be the amplitude when it completes 200 oscillations? When it completes 200 oscillations, after 100 oscillation, amplitude is 1/3. 100 to 200, that is another 100 oscillations. After another 100 oscillations, the amplitude should be another 1/3. That is, previously it was 1/3. Now 1/3 of 1/3, that is 1/9. So the amplitude becomes 1/9. So correct option is D. Correct option to the question number 28 is D. Now let us take the question number 29. The function sin omega t minus cos omega t represents a simple harmonic motion with period pi by omega, a simple harmonic motion with a period 2 pi by omega, a periodic but not simple harmonic motion with a period pi by omega, a periodic but simple harmonic motion with a period 2 pi by omega. So first of all, we have to find whether the motion is periodic. The motion must be periodic because there is some sine or cosine function. So first of all, we have to see whether the motion is simple harmonic or periodic only. Given that, let y equals to sin omega t minus cos omega t. Multiplying and dividing by root 2, we get root 2 into 1 by root 2 sin omega t minus 1 by root 2 cos omega t. We may put 1 by root 2 equals to cos pi by 4 and 1 by root 2 for the second case as sin pi by 4. Then the bracketed quantity becomes sin omega t cos pi by 4 minus cos omega t sin pi by 4. That is your sin omega t minus pi by 4. And this sine function y equals to root 2 sin omega t minus pi by 4, we have seen in so many cases that it must represent SHM, because if we differentiate it y with respect to t twice, first times we will get sine to cosine, next time cosine to minus sine. So acceleration will be proportional to minus y. So the motion must be SHM and the time period is 2 pi by omega. So our correct option is B, a simple harmonic motion with a period 2 pi by omega. So the correct choice of the question number 29 is B. Now let us take the question number 30. In this question, two simple harmonic motions are represented. The amplitudes are in the ratio. For the first one, amplitude is 10 unit, but It is not obvious in the second one. x2 equals to 5. Taking root 3 common, we get 5 root 3. So here root 3 sine 3 pi t plus cos 3 pi t. Now this is a is root 3 and b is 1. So root over of square of these two factors, root 3 whole square. Root 3 whole square is 3 plus 1. Root over of that is 2 into 2 by 2. So dividing and multiplying by 2, we get 10 root 3. If we put this factor as cosine term cos pi by 6 and this is sine pi by 6, so it is equals to 10 root 3 sine 3 pi t plus pi by 6. So x2 equals to 10 root 3 sine 3 pi t plus pi by 6. So for the second SHM, amplitude is 10 root 3. So the required ratio is, for the first one it was 10, for the second one it is 10 root 3. So the amplitude ratio is A1 is to A2 is 10 is to 10 root 3, that is 1 is to root 3. So 1 by root 3, B is the correct answer. So the correct choice of the question number 30 is B. Now let us take the question number 31. The uniform electric field E, 10 to the power 4 Newton per Coulomb, an electron is accelerated from rest. The velocity of the electron when it has travelled a distance 2 into 10 to the power minus 2 meter. So we have to calculate the velocity of the electron. When it is subjected to some electric field, a force will be exerted. That is why we will get an accelerated motion force on the electron. Force equals to small e into capital E. So acceleration equals to E by m. So when it traverses distance x, its velocity v equals root over 2a into x. That is your root 2a means E by m into x. 2 into E by m is given. E by m for electron is 1.8 into 10 to the power 11. E, electric field intensity, is 10 to the power 4 Newton per Coulomb. And x is 2 into 10 to the power minus 2 meter. 2 into 10 to the power minus 2 meter. Hence, the calculation gives 1.8 into 2 into 2, that is your 7.2 into 10 to the power 13. So this is 72 root 72 into 10 to the power 6, that is 6 root 2 into 10 to the power 6. Root 2 means 1.4, 1.4. So that is 8.4 into 10 to the power 6, nearly 0.85, 8.5 into 10 to the power 6. So D is our correct choice. So the correct choice to the question number 31 is D. Now let us take the question number 32. Force between two identical charges placed at a distance r in vacuum is F. So F equals to Q square by R square. Taking, they are placed in vacuum, so K equals to 1. Dielectric constant is taken as 1. Now a slab of dielectric constant K equals to 4 is inserted between the two charges. The thickness of the slab is R by 2. The force between the charges becomes. So the force F equals to, now F equals to Q square divided by, we have to calculate the effective distance. Now the distance in vacuum is R by 2. And within the plate, it is root K into R. Thickness of the plate R and root K is 4. Its whole square equals to Q square by R by 2. Here 2 will come out from the root and this 2 will be cancelled out. R plus R by 2, 3R by 2 whole square means 9 r square by 4, that is 4 by 9 into r square. So this is 4 by 9 into f. Q square by r square is f. So D is the correct choice. So the question number 32 having correct answer D. Now let us take the question number 33. In question number 33, a charged particle of mass m and charge q is released from rest in an electric field at constant magnitude E. The kinetic energy of the particle at time t is. The particle is within the electric field, so a force will act on it, F equals to q into E. Hence the acceleration of the particle F by m equals to q into E by m. So the kinetic energy in time t, kinetic energy means is calculated as half mv square. So you have to calculate the velocity after time t. It is subjected to uniform field, so acceleration is uniform. So the velocity after time t is at equals to q into E by m into t. Hence the kinetic energy half mv square equals to half m. V square means q square E square t square by m square. That is your q square E square t square by twice m. Q square E square t square by twice m, that is A. So the correct choice of the question number 33 is A. Now let us take the question number 34. In question number 34, a electric dipole is placed at an angle of 30 degree with the electric field of intensity 2 into 10 to the power 5 Newton per coulomb. It experiences a torque equals to 4 Newton meter. Calculate the charge on the dipole if the dipole length is 2 centimeter. So, torque is given. Torque on a dipole, when it is placed at an angle theta, is tau equals to Pe into sine theta. So when the field direction making an angle theta with the dipole, the torque acting on the dipole is Pe sine theta. Here torque is 4 Newton meter, so tau is 4. P, we have to calculate P at first. And E is 2 into 10 to the power 5 Newton per coulomb. And sine theta is 30 degrees, sine 30 is half. So P equals to 4 by 10 to the power 5, so 4 into 10 to the power minus 5 coulomb meter. Now the distance in between the two charges is 2 centimeter. P equals to 2 into Q into L, Q into 2 into 10 to the power 2 centimeter means 2 into 10 to the power minus 2 meter equals to 4 into 10 to the power minus 5. So Q equals to 2 into 10 to the power minus 3. That is 2 millicoulomb. 2 millicoulomb. D is the correct answer. So the correct choice of the question number 34 is D. Now let us take the question number 35. In question number 35, we see that consider an electric field equals to E0 into x, where E0 is a constant. The flux through the shaded area, here in this shaded area we have to calculate the flux through the area. So what to do? Field intensity is given, so we have to calculate the area of the parallelogram here. Now we consider it as the point A having coordinate 0, A0, and this is B having coordinate A0, A. So the vector OA equals to what? AJ, because x and y coordinate is 0 for the 2 points. So this is A into J. And OB vector equals to what? Here OB vector is AI plus AK, because y component is 0 in both the cases, for both the coordinates. Now we have to calculate the area OA cross OB. OA cross OB equals to A square into J cross I means minus K, and plus A square into J cross K is I. So that is your A square into I minus K. What to do? You have to calculate E dot ds. E dot ds. This is actually ds. E dot ds. What is E? E is E0x. That is E0I according to us. Dot. E0I dot A square into I minus K. So that is E0 into A square. I dot I1 but I dot K0. So E0 into A square is the correct answer. So the correct answer to the question number 35 is E0 into A square. That is our correct choice is C. E0 into A square. Correct choice is C. So the correct choice to the question number 35 is C. Now we see the question number 36. For the question number 36, 3 infinitely long charge sheets are placed shown in figure. The electric field at P. So there is a point P. We have to calculate the electric field. For the lowest charge, it is in the upward direction. So the field intensity is minus sigma by 2 epsilon 0 as its surface density of charge is minus sigma. For the second charge, it is also in the upward direction. So minus sigma by 2 epsilon 0 minus 2 sigma is the surface density. So here intensity at P for the second plate is minus 2 sigma by 2 epsilon 0. For the third plate, it is in the downward direction. So you have to put one minus sign here by 2 sigma 0. So that is your 2 epsilon 0 is being HCF minus sigma minus 2 sigma minus sigma. That is minus 4 sigma by 2 epsilon 0 minus 2 sigma by epsilon 0. And it is in the z direction minus 2 sigma by epsilon 0 into K. So B is our correct answer. So the correct choice of the question number 36 is B. Question number 36 is B. Now let us take the question number 37. The resultant capacitance between A and B is there are several capacitors. 3 microfarad, 2 microfarad, here 3 microfarad, 3, 2, 3 microfarad, 3 microfarad, 3 microfarad and 3 microfarad. We have to start from the right end. Here 3 microfarad capacitors, 3 microfarad capacitors are in series. So the equivalent capacitance of the combination of the 3 is 1 microfarad. When 3 microfarad capacitors, 3 of them are connected in series, equivalent capacitance is 1 microfarad. So the equivalent 1 microfarad and these 2 microfarad are in parallel. So the combination will give you again 3 microfarad combination. If we put here 3 microfarad, neglecting other portion, then 3 microfarad capacitors again in series combination, their equivalent capacitance is 1 microfarad, and that 1 microfarad capacitance is parallel with 2 microfarad capacitor. So it will yield only 3 microfarad capacitor. These 3 microfarad, 3 microfarad and 3 microfarad, 3 microfarad capacitors again in series combination. So the equivalent capacitance is 1 microfarad. So the correct choice of the question number 37 is A. Now let us take the question number 38. The circuit shown in figure, a potential difference of 60 volt is applied along AB, the potential difference between the points M and N. Here, the potential difference in between these of these capacitors C is also 60 volt because it is parallel to the source. Now there are 3 capacitors having total potential difference 60 volt. There are 2C capacitor. They are in series. So we may consider it as there are 2 capacitors. One of them is C and another is series combination of 2C. 2C capacitors gives you another C. And they have total voltage drop. If it is 60 volt, so the total voltage drop against 3 capacitors is 60 volt. Now, these 3 has become 2 capacitors of capacitance C. So, each having potential drop should be 30 volt. So the right end capacitor of capacitance C having 30 volt voltage drop. So the correct choice of this question is D. So the correct answer of the question 38 is D. Now let us take the question number 39. In question number 39, the figure shows two identical parallel plate capacitors connected to a battery with the switch S is closed. The switch is now open. At first the switch was closed, so the energy of each capacitor was half CV square. Now the switch is opened and the free space between the plates of the capacitor is filled with a dielectric of constant 3. Dielectric of constant 3. Find the ratio of total electrostatic energy stored in both capacitors before and after the introduction of dielectric. Before introduction of dielectric, the energy of each capacitor was half CV square, total energy was CV square only. After the switch is off, one of the capacitor is connected with the battery and the dielectric constant of the dielectric slab is 3, so capacitance of each capacitor is thrice C. So when it is already connected with the source, its energy is half into 3C into V square. So energy of the capacitor A is now half into 3C into V square. Whereas, which is detached from the battery, that capacitor will have charge constant, so its energy is Q square by 2C. Q means CV whole square by 2 into C means, now C is thrice C. So this is C square V square by 6C, that is 1/6 CV square. So the total energy of the combination is number 1 3C by 2 into V square plus 1/6 CV square. So 3C by 2 into V square plus 1/6 CV square, that is 9 CV square plus CV square, so 10 CV square, 10 by 6 CV square. So the energy ratio is CV square is to 10 by 6 CV square equals to 6 is to 10, that is your 3 is to 5. So the energy ratio is 3 by 5. C is the correct answer. So the correct choice to the question number 39 is C. Now let us take the question number 40. It is a drift velocity related problem. The drift velocity of a free electron or free electrons in a conductor is V when a current I is flowing. We know the drift velocity equation, I equals to NAVD into E. If both the radius and current are double, then the drift velocity. Current is twice E. There is no change in N, but both the radius, if radius is double, then cross-sectional area is 4 times. VD less, take it as VD dash. If both the radius and current are doubled, and E is as E, then drift velocity becomes. Now, it is as VD dash equals to twice I by 4A N into E, that is I by 2A NE. But whereas VD was earlier I by NAE, so it is half. Actually, this is VD by 2. Comparing this equation from equation 1, if we put I by NAE equals to VD, then this is VD by 2. So VD by 2 is our correct answer. V by 2, actually it is not given as VD, it is given as V. So our correct answer is V by 2. So the correct choice of the question number 40 is B. Now let us take the question number 41. In question number 41, we see that two wires that are made of two different materials having specific resistances are in the ratio 2:3, length 3:4, area 4:5. The ratio of their resistances, we know that resistance R equals to rho into L by A. So R1 by R2 equals to rho 1 by rho 2 into L1 by L2 into A2 by A1. So now rho 1 by rho 2 is 2 by 3. Rho 1 by rho 2. L1 by L2 is also 3 by 4. But A2 by A1 is actually 5 by 4. So it will cancel out as 2, 3 will be out. This is 5 by 8. So the required ratio is 5:8. C is the correct answer. So the correct choice of the question number 41 is C. Now let us take the question number 42. In this question, we see that in the given circuit figure, the voltmeter records 5 volt. Voltmeter records 5 volt. Then what is the voltage drop against 50 ohm? That is also 5 volt, because battery voltage is 10 volt, the resistance of the voltmeter. Now, 50 ohm resistance and this combination, voltmeter 100 ohm resistance combination and 50 ohm resistance are in series, so they will have same current. When they have the same voltage drop, 5 volt each, then they have the same equivalent resistance. So V be the resistance of the R be the resistance of the voltmeter, and it is connected in parallel with the 100 ohm resistance. This combination will have resistance equals to 50 ohm. R 100 R by 100 plus R, the equivalent resistance of R and 100 ohm equals to 50, 52. 2R equals to R plus 100. Hence, R equals to 100 ohm. So our correct choice is B. Correct choice to the question number 42 is B. Now let us take the question number 43. In question number 43, we see a circuit diagram. What to do? The equivalent resistance between the terminals A and D. Here is the terminal A and here is the terminal D. We have to calculate the equivalent resistance. The 8 resistances, 5 ohm, 10 ohm, then 5 ohm, then 10 ohm, then 10 ohm, then 5 ohm, 10 ohm and 5 ohm. Equivalent resistance between A and D have to be calculated. So these resistances will be ineffective here. So we may first of all neglecting these two resistances. Now, these 4 resistances, 4 10 ohm resistances are as connected as Wheatstone bridge combination. And when Wheatstone bridge combination is there, the equivalent resistance of the combination is 10 ohm. So the equivalent resistance is 10 ohm instead of these 4 resistances. But to calculate the equivalent resistance between A and D, now by the simplification we get there are only 3 resistances, one 5 ohm, one 10 ohm and one 5 ohm, and they are connected in series. So the total resistance is 5 ohm plus 10 ohm plus 5 ohm, that is equals to 20 ohm. So the equivalent resistance between A and D is 20 ohm. Now let us go to the next question. 4 cells of identical EMF E and internal resistance R are connected in series to a variable resistor. The following graph shows the variation of terminal voltage of the combination with current. The EMF of each cell. We know that when I equals to 0, V equals to E. So when I equals to 0, V equals to E, that is 5.6 volt is the equivalent EMF of 4 cells, and they are connected in series. In series combination. They are connected in series combination. Having EMF E. So 4E equals to, that is 5.6 volt. E equals to 1.4 volt. So our correct choice is A. Correct choice to the question number 44 is A. Now let us take the last question. In the last question, we see that three identical resistances, each of 10 ohm, are connected as shown in figure. The maximum power that can be consumed by individual resistor is 20 watt. What is the maximum power consumed by the combination? Now, let us take the third resistor. There are three resistors, each of resistance 10 ohm. Let us take the third resistor is consuming maximum power and it has current I. Other two identical resistors will have current I by 2, and we know that power is proportional to I square. So other resistors having half the maximum current, so they will have power 1/4 is proportional to I square actually. So the power consumed is 1/4 the maximum power. Maximum power is 20 watt. So for these two 10 ohm resistor, power consumption is 20 by 4 is 5 watt. For the lower one, it is also 5 watt. And this resistor is taking all the current, and it will actually consume maximum power, that is 20 watts. So the total power used by the combination is 20 plus 5, 20 plus 5 plus 5 watt, that is your 30 watt. So the correct choice is C, and that is the end of the descriptive type answer here. Now we will go through the multiple choice type answer. Multiple choice type answer, we will read it as at a glance. Number 1 question having correct option A, 2C, 3D, 4A, 5C, 6B, 7A, 8A, 9A. 10B, 11A, 12B, 13B, 14B, 15D, 16C, 17D, 18D, 19C, 20A, 21A, 22B, 23C, 24B, 25D, 26A, 27B, 28D, 29B, 30B, 31D, 32D, 33A, 34D, 35C, 36B, 37A, 38D, 39C, 40B, 41C, 42B, 43B, 44A, 45C. Now, that is the end of mock test 7. Our next mock test will be mock test number 8. Subject is physics, and our topics for that mock test is physical optics, geometrical optics, EM theory, electromagnetic induction and AC, and mechanics. Probable date of exam is 23rd June 2022. That's all. Goodbye.